Before I go on to the next video, I think that it is pretty helpful if I were to do something that deals with the constant k. Okay, normally this is in terms of your transfer function, alright, but you have no constants in this case. Alright, so this is why we just leave this as this one will do. Alright, but if however if we have a certain constant, alright, if you have a 3 times something like this, okay, then what can we do? Alright, something is different, right? Because the constant k over here will be different in your digital domain. Okay, so we need to evaluate the constant k. Alright, and therefore in this case I'll just add in a k into our transfer function. This is our transfer function z domain, right? Or this is the final one, so to speak. Because when e minus infinity is equals to minus 1, right? So I'll just write as minus 1 is plus 1. But anyway, so I add in the k over here, and this whole thing is your hz. So how do we find the value of k? And therefore we're gonna utilize our initial transfer function in the S domain. Okay, so in the S domain, alright, S plus 2 over here, I'll just remove the hidden zeros because I don't need this anymore. So whenever you evaluate your k, don't include your hidden zero, just take it out. Okay, and therefore I'll set this the initial condition as S is equals to 0, because when you never input your frequency, your machine doesn't move, and this is just the one that you want, right? The initial one. Okay, so I'll just sub it as S is equals to 0, and if I were to sub it as S equals to 0, 0 squared is 0, 4 times 0 is 0, you have 2/3. Alright, so in the S domain, this is equals to 2/3. Alright, so in the S domain, it is equals to 2/3. Alright, in the Z domain, it will also be 2/3. It's because it's just some numbers. It's not in terms of whatever frequency. Alright, it's just some numbers, so you won't change, you won't map anything. It'll just be some other arbitrary constant 2/3. However, in such of a case, so I'll just write the condition as when S is equals to 0, okay, your transfer function is equals to 2/3, while your Z, you also need to change. Alright, because if your S is equals to 0 in the S domain, which is over here, this is equals to 0, you know that when you plot inside the Z domain, it's at the point of 1, doable, and so therefore you just sub your Z as equals to 1. So when S is equals to 0, Z is equals to 1. So I'll just simply sub it in as 1, 1, 1, 1. Okay, so what I will have is equals to 2/3. Alright, so 1 minus e minus 2t is this one. 1 plus 1 is equals to 2. 1 minus e minus t. You see, I didn't change anything. Your k is still your k over here. Okay, so in the initial condition of S equals to 0, Z equals to 1, you can find your k already. Okay, so therefore what I can do, I'll just simply switch sides. So I'll just bring this upwards to the top. Okay, or I remove all the lines. So this denominator, I'll just bring it downwards. Okay, and then I'll just bring everything. Give me a while. Okay, so I'll just bring everything over here. Okay, so I'll just simply rearrange to get my k. Alright, so my k is equals to this one. Alright, so our initial transfer function is this one, and then we have a k, right, which is equals to your transfer function in the Z domain. Now since we know our k is equals to this form, I can just simply bring it all the way to here. Wow, it's way too big. I'll just crop it smaller. Okay, as you can see, then we have this thing already. Alright, please always remember that you need to add in the k. Okay, but as for whether do you need to add in the k, if you have no, if for example in this case we have no k in the S domain, do we need to find the k? This is the question that I don't know, but I think for safe, you have time, just do it out, because you're just simply doing subbing in and rearrange, which is pretty fast step. Alright, so if happen that they don't need this one, at least you got this one, then you are still marked correct. Alright, so therefore just leave it as that will do. Okay, so normally for me, I think I'll just leave it as a k, or a k times whatever constants or whatever transfer function that you have. Okay, so later on we'll do, now officially we'll start to do a few examples to actually strengthen your understanding. See you there then. Where am I?